Good morning, geometry family, GeoFam. All right, we are going to continue learning about probability. We've done two-way tables, we've done or without two-way tables. Now we're going to get into multiplication. All right, so these are the and events that on the two-way tables we could see, right? We would just circle it and we'd be like, oh, there's the intersection, right? But now that we don't have the table, we have to follow a formula. It's actually a pretty easy formula. Whenever you see the word and you don't have a table you can look at, then you're going to be doing multiplication for independent events. The thing about it though is dependent also has multiplication. This formula looks a little bit weird. What it's saying is you multiply A and B, but B has to change based on whatever happened in A. All right, so the big thing you're going to look out for is did not replace it, right? If you did not replace it, then this second fraction has to change. Whereas up here, you replaced it. If you replace whatever you did in event A, then event B is ready to go. All right, so let's just dive on in so you can see what these problems are all about. We've got 10 beads, 2 black, 3 white, 5 red. Beads are selected one at a time. Find the probability of selecting a white bead, replacing it, and then selecting a red bead. All right, so if we are replacing it, then this is considered independent events where we multiply them together. All right, so let's start with the white bead. There are 3 white beads out of 10. So we have 3 out of 10. And, so and means multiply. All right, so now we're going to multiply the red bead probability. Probability of a red bead is 5 out of 10. All right, so when you're multiplying fractions, you go straight across. So this would be 15 out of 100. And then you can reduce those fractions down if you want. You can write it as a decimal if you want, or a percent. Doesn't matter to me. All right, next up, find the probability of selecting a white bead and not replacing it, and then doing a red bead. So this is a lot like number 1, but we don't put the white bead back. All right, so we reach into the bag. There's 3 white beads out of 10. Then we go to select a red bead. There are still 5 red beads in there, but what changed is now the denominator. Since we took a white bead out for this first draw, we're down to 9. You might say, but Mrs. Hamilton, how do you know it was a white bead? What if it was a black bead? Okay, well, this is all theoretical. We don't really know what happened. All right, so theoretically, we're assuming that we took a bead out for this fraction, so that's why we're down to 9. Okay, multiplying fractions, you go straight across, so that's 15 over 90. You can reduce that fraction down if you want. Make it a decimal or a percent, it doesn't matter to me. All right, next up, find the probability of selecting 2 black beads with replacement. All right. So there are 2 black beads out of 10. So 2 out of 10 for our first go, but we're going to do this 2 times. So now we try again. All right, notice it is with replacement, so my denominator stays the same. So I go in to reach and there's a 2 out of 10 chance. I put the bead back. Then I do it again, 2 out of 10 chance. So we get 4 out of 100. You can reduce that fraction down if you want. All right, find the probability of selecting 3 white beads without replacement. Okay, so we're going to select a white bead, and then a white bead, and then another white bead. All right, since I have more space, I'm going to write more here. It's without replacement. So once we take a bead out for this first draw, we're down to 9 beads, and then we'll be down to 8 beads, and so on. Okay, so there are 3 white beads out of 10 when you first go. We don't put it back, it's without replacement. So now we're down to 2 out of 9. And we don't put it back, so now we're down to 1 out of 8. All right, so we're taking 1 white bead out at a time. All right, so multiplication, you would go straight across. 3 times 2 times 1 is 6. And then down here in the denominator, 10 times 9 times 8 is 720. You can turn it into a decimal if you want. That decimal is 0.008, so it's highly unlikely. All right, the probability of getting 3 white beads in a row, highly unlikely. All right, let's look at the next page. This is the page I want to see a picture of when you're all done on Edmodo. All right, let's see how far we can get here before our time runs out. A bag contains 5 red, 3 green, 4 blue, and 8 yellow marbles. That's 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So we have 20 total. Find the probability of randomly selecting a green and then a yellow if the first marble is replaced. All right, well, let's start with green. We have 3 greens out of 20. Then we're going to select yellow. There's 8 yellow. And it's still out of 20 because we put that first marble back. All right, so multiplying straight across, you get 24 over 400. And I know a lot of you don't have calculators, so I'm okay if you just leave it unsimplified, okay? All right, number 2. We've got a sock drawer that contains 5 pairs of each color socks. So we have 5 white, 5 green, 5 blue. So there's 15 total socks. 15 total socks. All right, we want the probability of randomly selecting a pair of blue socks, replace it, and then select a pair of white socks. Okay, so blue socks, we have 5 pairs out of 15. We put it back, whatever we drew, and then we draw again, this time hoping for a white. White is 5 out of 15. All right, so multiplying straight across, 5 times 5 is 25. 15 times 15 is 225. Yeah. You guys remember how to do some reducing? I feel like maybe I should refresh your memory, right? 5 goes into 15 3 times. So this is the same thing as saying 1/9. You remember those little tricks? Maybe? Okay. All right, number 3. In a standard deck of cards, if you don't play cards, there's 52 cards in a standard deck. What is the probability of picking a diamond and then another diamond without replacement? And again, if you don't play cards, there's 13 diamonds. All right, there's 13 of each suit. That's a weird looking diamond. Ooh, I'm an artist. Okay, so it's without replacement. So we start off with 13 out of 52, right? Those are the odds of picking a diamond. Whatever happens in the first draw, bloop, I don't put it back in. I set it off to the side. So now I'm down to 51 cards. We're assuming that a diamond happened on the first draw because that's what we were after for this first fraction. So now there's only 12 diamonds, right? It's all theoretical. We don't really know what happened, but we're assuming this first draw was the diamond. We take it out and we don't put it back. So now we're down to 12 out of 51. Multiply straight across. So we have 13 times 12, which is 156. 52 times 51, which is 2,652. Oh my. I'm curious what those odds are. Let me turn it to a decimal. So there's like a 6% chance. I wouldn't put my money on that if you're in Vegas. All right, check out number 4. Randy has 4 pennies, 2 nickels, and 3 dimes in his pocket. If he randomly chooses 2 coins, what's the probability they are both dimes if he does not replace the first one? All right, well, let's see what our total is for our denominator. 4, 5, 6, 7, 8, 9. So we have 9 coins. Okay, we're picking dimes. So there's a 3 in 9 chance that you get a dime. All right, but we're going to do it again because it says both. So if we do it again and we did not replace the first dime, so now we only have 8 coins and we're assuming that dime was taken out on the first run. All right, so multiplying straight across, you get 6, and then 9 times 8 is 72. And you can reduce that down if you want, turn it into a decimal if you want. You get 0.08. All right, number 5. 2 students are chosen at random from a class of 30. What's the probability both you and your friend are chosen? Okay, so out of 30, we've got you and a friend. All right, so there's 2 out of 30. Okay, we're going to assume you or your friend was selected. So now we're down to 1 out of 29. All right, so multiplying that straight across, you get 2 out of 30 times 29, 870. 2 divided by 870, 0.002, highly unlikely. So if you and your friend happen to be put together for a project and your teacher says, oh, I put you randomly together. No, you didn't. All right, highly unlikely. Your teacher probably put you together on purpose. Wasn't that nice? Okay, number 6. A test includes several multiple choice questions, each with 5 choices, right? Think of it A, B, C, D, E, right? Multiple choice. Suppose you don't know the answers for 3 of these questions, so you're gonna guess. What's the probability of getting all 3 correct? Okay, so let me draw a little spacing here. All right, so for the first question, right, because we have 3 questions we're doing, there's 5 multiple choice answers and only one of them is right. Right? 1 in 5 chance of getting that one right. When you go on to the next question, it doesn't matter what happened before, right? The probability resets itself. It's still a 1 in 5 chance on that problem. Then you move on to question number 3, still a 1 in 5 chance for that problem. So for these 3 problems, the probability of getting 1 right out of 5, right? So we have 1/5, 1/5, 1/5. So 5 times 5 times 5 is 125. Ooh, so that's not good odds at all. Don't guess. It is not good to guess. Definitely need to narrow that down so it's not out of 5 anymore. Okay, number 7. Using the letters in the state Arkansas, find the probability of picking an S and then an A without replacement. Okay, how many letters do we have? 1, 2, 3, 4, 5, 6, 7. All right, so there's 7, right? Visualize the word Arkansas and you cut it out. So you've got these 7 cards with these 7 letters. All right, so the first letter we're going to try and pick is an S. How many cards have an S on it? 1, 2. All right, so there's 2 S's. Then we go back and we want to try and get an A. But this first card we didn't put back. So whatever we drew, we're down to 6 now because we didn't put that first card back. How many A's are there in our stack? 1, 2, 3. 3 A's. All right, so those are the S's and those are the A's, and multiply straight across. You get 6 out of 42, and of course you can reduce that down, make it a decimal. That's 0.14. All right, and last but not least, Arkansas again. Find the probability of picking a K and then an N without replacement. All right, there's only 1 K, so 1 out of 7 for K. All right, this is my K. All right, then we're gonna go and try and pick an N. We didn't put this first card back, so whatever it was, I don't know, we're down to 6 cards now. How many are theoretically N? Just 1. Remember, this is all theoretical. All right, what happens in the real world doesn't always match up perfectly, but this gives us some basis of the odds. Okay, so we have 1 and 7 times 6, 42. All right, 1 in 42 chance. Highly unlikely, so don't put your money on it, folks. Okay, so snap a picture of this and send it to me on Edmodo, and tomorrow we'll keep practicing these. Have a good Monday. Miss ya.